Let's take a look at comparing fractions. Sometimes we want to find out which fraction is bigger, which fraction is smaller, or if the fractions are even equal to each other. All right, so when we're taking a look at a simple fraction comparison, this example that I've given you right here is fairly straightforward. We can clearly see that 3/4 is larger than 1/4. And when we look at our drawing here, we can see that this drawing here is clearly has more area of the object shaded than this area here, which is 1/4. Well, sometimes things aren't quite so clear, and that is when the denominators are not alike and they're in fact different. So let's take a look at an example of that. Here's a very simple example to demonstrate what we're talking about. We have two unlike denominators here. We have on the one side we have 6, and on the other side we have halves. So we have 2/6 versus 1/2 to see which one is in fact greater. Now, where students get into problems is they start by looking at the denominator and say, oh, the denominator is way bigger. The 6 is bigger and the 2 is bigger. Therefore, 2/6 must be larger. And that is in fact wrong. In fact, when we look at this number here, the bigger that number, that means the smaller that the parts are. Because when we look at the entire object, that means how many parts it's broken up into. So if you were to take a whole pizza and you were to cut it into 10 pieces, as opposed to taking a whole pizza and cutting it into 4 pieces, then obviously the pizza that's cut into only 4 pieces is going to be a lot larger. All right, so let's take a look here and take a look at an actual drawing. Well, in this case, this one here is 2/6, and this one here is represented as 1/2. Well, in order for us to compare the two fractions, we first have to make sure that these parts are equal. So we have to have the two objects cut into the exact same amount of parts. This is what we call finding like denominators. So we have to find common denominators in order to compare two fractions. So if we first take a look at this, we can see that this is broken up into 6 parts. Well, we can quite easily break this one up into 6 parts just by drawing in a couple more lines. And so now these shapes are got the exact same amount of parts. Now we can just count how many of those parts are in fact shaded. And when we look at this, we can see that half of it is still shaded, but in fact there are 3 out of the 6 parts that are currently shaded. And since we know that 3/6 is going to be more than 2/6, we can simply say that 1/2 is going to be larger than 2/6. Now let's take a look at this problem. We have an issue of 3/5 and 2/3 that we're trying to discover which one is greater. So what we have to do is we have to first convert these two denominators to make sure that they are common. In other words, they're the same. So from what we can remember about lowest common multiple, LCM, we know that we can simply multiply out or skip count out to find a number that both of these will be the product of. So if we have 3 here and we have 5 here, and we were to actually draw in a table, so this would be times 1, times 2, times 3, times 4, times 5, times 6. Now all we have to do is just kind of skip count our way across. Okay, 6, 9, 12, 15, 18. And we could do the same thing here. 5, 10, 15, 20, 25, 30. Well, now what we've got is we've got a range of numbers, and we can find the lowest common multiple of the two numbers. In this case, we can see that the first one that comes up for both is 15. So what we want to do is we want to convert these denominators to over 15. The question is how do we do that? Well, in this case, how much do we need to multiply 5 to in order to get to 15? And in this case, it's 3. And what we do to the bottom, we also have to do to the top. So 3 times 3 is 9, and 3 times 5 is 15. And we have to do the exact same thing on the other side, except we have to determine how much do we have to multiply 3 by in order to get it to 15. And in this case, it's 5 and 5. And so now we have 2 times 5 is 10. And now we've got a situation where we're comparing like denominators, and it's easy for us to see that clearly 10/15 is larger than 9/15. So if we go back to our original equation, we can see that 2/3 is actually larger than 3/5.